we must acknowledge that many patient records look the same. Family members, people with the same names, twins, common names. Theoretically, at least, every patient should have one unique record in the MPI, right? But how confident can we be that the patient record we found is actually the correct one? How can we be sure that this record does not belong to another patient? And moreover, can we really be sure that we found all of the patient's records? With such a high duplicate average count in industry, 8% by AHIMA measurements, we have a 1 out of 12.5 chance of getting an incomplete record. And this is because our EHR searches are problematic. That is to say, the EHRs assume perfect data because it's text-based search. And that's a huge limitation and the reason for all of our duplicates. Because if the data is not exact, then we don't find the patient record. It's really quite that simple. An EHR search, frankly, just misses the mark when data is not perfect. The conclusion is apparent. When we have data errors in the MPI, EHR searches do not work well. The more data errors we have, the more duplicate and overlay records we will have. These small data errors are directly related to our duplicate and overlay problem. So let's understand a little bit about the data errors that we're talking about. They accumulate day by day. They're accidental. Mistypes, individuals just flipping characters around, transposing characters. And fortunately, no single error is usually catastrophic. But there's an old saying, you probably heard it, death by 1,000 cuts. Every misspelling, every address error, every piece of missing information is going to contribute to those duplicate error problems, or worse, overlays. It's truly death by 1,000 cuts. Really what it comes down to is data errors equals search failures. And search failures are what cause duplicate records, and sometimes overlays. When we have enough errors in our EHRs, the EHR search will work correspondingly worse. These small data errors are the root cause of duplicate and overlay records. And that brings us to the topic of modern search. And let's define modern search, saying that it must work with errors in the MPI because we know we have many errors already, as we discussed. The search must be accurate. We can no longer afford to keep on saying we can't find the patient, so therefore we're going to create a new record. The search must also be fast. That's critical. In the high-speed, high-pressure registration offices for the emergency department, the admissions office, or in scheduling offices where the phones are always ringing, our search has to find the patients as quickly as possible. There's no time to spare. The search must also be user-friendly. Think about it. We get on the internet and use internet search easily and without training. Yet when we use EHRs, there's often a lot of training and techniques that go into using their tools so we can find our patients. The search also has to be smart. Just like Google, when you search, say, for movies, it knows your location. It understands the context in which you're searching. And it's the same thing with patient search. If I'm searching for a patient record, say Jim Hoover, my name, it should also understand there's probably a record under James Hoover, as well as James Huber, where someone misspelled my name because I didn't pronounce it as clearly as I could, and so on and so forth. We've already talked about it must work with errors in the MPI, and that's the fundamental driving principle for modern search in healthcare. Has to. Our data has errors by definition, and our search needs to work with errors by definition. And that leads us to our final requirement for modern search, that it has to be fault tolerant. In other words, search can still find patients even when there are a lot of errors in what we type in their name in the search fields or in what is in the database, the MPI itself. Modern search must tolerate errors in every location and still give us the results. The question now becomes, what is fault-tolerant search? We're not going to go into it in detail in this presentation, but understand modern search, smart search, works on data that's standardized, or what's called normalized. Standardizing our data is a critical component of modern search, and very few organizations do that today. The smart search also should work with data errors that are near misses, addresses or names off by a few letters or numbers. It should work with abbreviations, FIRST for FIRST, or AV for Avenue. These typos and misspellings should just be a mere inconvenience to the search, not a showstopper like it is with EHR searches. And this fault tolerance is important because many records have multiple errors. We call records with more than one error a compound error. And those give us especially difficult problems during patient search and patient matching. So let me give you an example of what we're going to demonstrate today. We're going to try to find a record of a patient with the name Janet Montague. The first thing we're going to do is reverse her first and last name. Then we're going to introduce errors in the name, the first name Benit instead of Janet, the last name ultimately Nantaglu instead of Nantague, and then we will perturb the address, removing digits, misspelling the street name, ultimately till we break the search again. Then we might introduce a telephone number or social security number and do the same. Change the data character by character until we see the point of failure. The important thing to consider is that most search systems, and probably all EHR systems, cannot find a patient with 10, 12, 15, 20 errors in the search data. Yet modern search, smart search, fault-tolerant search does and can. So let's get into that demo and I'll show you what we're talking about. So just like in the presentation, I'm going to put in the last name Montague and the first name Janet. We find the patient, and up pops the medical record, and the test patient is a picture of my mom. Shh, don't tell her I'm using her photos. We can check the score and see that it was perfect match for what we typed. But what if we reverse the first and last name? We will find the same patient, except the score is a little bit lower. We deducted part of it because the names were in the wrong location. Now we'll start to perturb the name. We'll search for Janet first, and we'll make some changes to the last name in a moment. Lower score 0.863, rather. But you see, we are still finding the same patient, even with a grossly misspelled first name in the wrong location. And the system shows we have 2 out of 3 characters that are incorrect, and 1 field that's reversed. Now let's mess with the last name, Montague. Let's make it Mantaglu. Add 3 more errors to the name. Now we've got 3 errors in the second name, in the last name, 3 errors in the first name, and the name's reversed for a total of 7 errors, and we still find the patient. That's incredible. Now let's make it Benit. Finally, we made the system fail. Finally. So what do? We add more information. This is the key part about overlays. The more information we type into the record, the more precisely we're going to dial into the correct patient. With this new approach to search, the best practice is to type as much information into the search rather than less. Now let's type in the street address. 2406 7th Avenue, or Ave, and we find the same patient. Let's mess with the address a little bit and maybe misspell 7th. Actually, not misspell. Let me correct myself to give an abbreviation. That's part of the smart search, using synonyms for things that might be spelled different ways. Let's change the number, remove a 0. Now we change the address. We maybe Avenue instead of Avenue, so we've got even more errors. We'll finally misspell 7th now. We'll make it 7th. I can't even pronounce it. We'll make it 7th now. And ultimately, when we remove the N, we make it fail. I don't want to go through every field because it gets monotonous, but let's just throw in the social security number. Let's get it correct to start. We have so many errors, 8 in the name. We have errors in the address. 1, 2, 3, 4, 5, 6, at least 6 errors in the address. Now we're making errors in the social security number, and eventually we're going to cause it to fail again. But this is the power of modern search, fault tolerant and smart. Now with 1, 2, 3, 4 errors in the social security number, it finally failed. Alright, I'm going to type in the home phone number, just for grins. So you can see, just adding a little bit more patterns that match, we can still detect the right record. And if I make some mistakes in the phone number, make a mistake in the front, maybe my finger slipped, I typed an 8 instead of a 9, you can see the score is still pretty high, 0.6. Change one of the other area code numbers or local code numbers, and then change the last digit. Finally, it should fail. Mercifully, no, it hasn't failed yet. Let's give it one more. One more error. Okay, it finally failed. You get the idea. Even with 21 errors, we still find the patient. It's not perfect, but it's pretty good. I hope you learned a lot from the presentation. My emails and contacts are available, so please feel free to reach out to me. And I hope some of it was useful for your organization.